My name is Barbara Dubach. We are going to talk in session 3 about the principles of resource revolution of the Resource Revolution trainer. In session 2, Cornice introduced decoupling as a response strategy to turn the risks or challenges into opportunities. In this session, we will introduce you to the 5 principles of the Resource Revolution enterprise as defined by Heck and Rogers in their book, The Resource Revolution. We will also provide some examples from companies of the experiment stage of the aeronautics transformation process defined by John Elkington. So what are the principles for the Resource Revolution enterprise? They are substitution, elimination of waste, increasing circularity, optimization, as well as virtualization and dematerialization. Before we dive into the 5 principles, let me say a few words about the experiment stage of the aeronautics transformation process. The experiment stage of the aeronautics transformation process requires an openness to disruptive or transformative change, and also includes frugal innovation. Frugal innovation is about how to do more with less. Rather than seeking to adapt Western products to developing world conditions, frugal innovators take the needs of poor consumers as starting point and work backwards. They, among others, strip products down to their bare essentials. Frugal innovators include companies such as car maker BYD from China, previously a battery company. Zeronauts in this stage are willing to break the rule. They are willing to embrace the role of failure in successful innovation and continue to learn by doing. So now let's have a look at the first principle, substitution. The guiding criteria for substitution is to first of all look at every single resource your company uses in its products and every single resource that your customers use or consume. At the next stage, look for higher performing or less expensive or less scarce materials that might work as substitutes. And also look at how substitutes can deliver superior overall performance. Now the question is, which materials need better alternatives? From a materials and environmental impacts perspective, the International Resource Panel's Priority Products Report suggests the following materials need better alternatives. They include fossil fuel, agricultural materials, especially animal products, extracting and refining materials such as plastics, iron, and steel. Hence, priority areas for innovations are energy and fossil fuels, agri-food, and materials. One example of a promising substitution material, for example in the building industry, is bamboo. It is one of the fastest growing plants, reaching maturity 3 times faster than on any other harvestable timber. And bamboo today is well established as a viable construction material, especially in developing countries, but also in coastal areas. The second principle, elimination of waste, includes measuring your input materials, energy and water, and comparing that with your delivered product and trying to understand all the waste factors in between. Are there leakages, scrap, idle machines, and interruptions? This is also the approach behind waste reduction as made famous by Toyota's Kaizen. Kaizen stands for continuous improvement and change for the better. The elimination of waste not only includes reduction of waste, but also reuse and recycling of waste materials. The Ellen MacArthur Foundation has highlighted also the economic benefits of recycling, putting forward a clear economic case for the concept of a circular economy. To eliminate waste, life cycle thinking, eco-design, new technologies need to be applied. For example, the arrival of 3D printing holds the prospect of leaving zero waste. While 3D printers initially only used plastic, they can now print in steel, titanium, gold, and other materials. It is also used to print various products, including hip replacements, smartphone covers, as well as car doors. Furthermore, resource interrelations need to be considered. For example, a water-carbon efficiency relationship, as highlighted by McKinsey in the 2000s. IBM is an example that has seen how integrated water and energy management at a single plant enabled it to achieve savings of $3 million while increasing output by 33%. This included a 27% reduction in water purchases, almost $1 million in water treatment savings, and $1.5 million in energy savings without incurring any capital costs. Circularity in business is about finding value in products after their initial use. Consider the progress made by the aluminium industry in moving towards closing the loop and the prospect of becoming an industry based on secondary production or above-ground mining. The key rule of thumb in circularity, noted by Heck and Rogers, is the tighter the loop, the greater the value captured, and the stronger the competitive differentiation. For example, reusing a phone is more valuable than reusing a chip, which again is more valuable than melting it or grinding it down to extract gold. One example is that in the US, eRecycling Corp works with cell phone service providers to offer customers, for example, $50 rebate on the purchase of a new phone if they return their old phone. Other examples to increase circularity are above-ground mining in electronics and gold. The technology provider ATMI took note of the fact that e-waste contains 100 times as much gold as the best ore in the world found in South Africa. Not being extracted, some 35% of the gold that is produced for medical, electrics, and industrial uses annually gets thrown away. In response, ATMI has developed a water-based solution that dissolves the gold and extracts it from e-waste. The possibilities of closed-loop circular systems in manufacturing include also remanufacturing. Remanufacturing has become increasingly significant in areas such as vehicle components, aircraft parts, compressors, electrical communication equipment, photocopiers, and print cartridges. One example is Caterpillar. They are probably the world's largest remanufacturer. About 70% of a typical machine can be reused, while another 16% is recycled. The fourth principle is optimization. Optimization is about maximizing efficiency and also effectiveness. A guiding principle for the aspiring resource-efficient company is to ask itself what expensive assets are used only a small part of the time, or what resource-intensive equipment is active without performing a function. This could be construction equipment, shipping containers, or trucks that return empty, or planes circling an airport waiting for congestion to clear. All these cases lend themselves to smart IT solutions that optimize routing, loading, or sharing. Opportunities for optimization in business exist at various levels and also in various sectors. System optimization can enable radical improvements in the use of electric motors. Electric motors can account for approximately 60 to 80% of industrial electricity use, driving pumps, fans, air compressors, and materials processing and handling. In China, electric motors used in industry account for around 60% of the country's total electricity production and consumption. The operational efficiency of these motors is 10 to 30% below international best practices, depending on the industry. Another example is that today many airlines pool resources at airport hubs and provide each other spare parts. Komatsu, a Japanese manufacturer of construction, mining, and industrial equipment, has created a market that enables customers to rent to and from each other. It is an example of a company converting equipment sales to services and introducing product services systems. The fifth principles of the resource revolution enterprise is virtualization and dematerialization. Virtualization challenges business models. It is therefore a concept that many companies struggle with, as it involves moving activities out of the physical world and or stopping doing things since they have been automated. For some industries or business models, this implies loss in revenues, such as a car manufacturer faced with customers driving less, because they are spending more time on social media, or a media company earning less from digital ads versus the ads in printed magazines. Without realizing it, many of the items we have been using only 5 or 10 years ago are now replaced by dematerialized products or services that fulfill the same function, often even better. These include books, radios, tickets, birthday cards, timetables, watches, manuals for managers or pilots replaced by iPads, for example, flashlights replaced by LED lights, drones replacing planes, or driverless vehicles. Importantly, the International Resource Panel Metal Risks and Challenges report has highlighted the need to be aware of the side effects of new technologies. Consider the case of metals and renewable energy. A shift towards a renewable energy system implies that the metal intensity of energy production will increase faster. Therefore, one has to be aware of the side effects and dematerialization will have to be complemented by recycling. Looking at these 5 principles of productivity and the examples highlighted, let's turn to you and ask yourselves which of these principles are most relevant for your company or most promising for your business. How does the rule of thumb in circularity, which says that the tighter the loop, the greater the value captured and the stronger the competitive differentiation, how does it apply to products offered by your business? Are you using system optimization and design for recycling approaches? And have you discussed this with your research and development departments or even that of your suppliers?